name is Cindy Hall, and I'm the Community Coordinator for NASA's Transform to Open Science program. We'd like to give you a little insight into some of these great campaigns that you're going to be able to work with. How is the global Earth system changing? This is a question that NASA scientists are investigating in the Mississippi River Delta, the world's 7th largest delta, through the Delta X campaign. A delta is a triangular-shaped landform that is formed from sediment that is deposited where a river meets the sea. Like many of the world's large deltas, the Mississippi River Delta is a dynamic system that is affected by both sea level rise and the effects of sinking coastal land. However, the Mississippi River Delta is unique in that it is sinking in some areas like the Terrebonne Basin, but growing in adjacent areas like the Atchafalaya Basin to the west. NASA scientists in the Delta X Airborne mission hope to better understand this dynamic delta by gathering remotely sensed and in situ data to study changes occurring to the Mississippi River Delta along the Atchafalaya and Terrebonne basins. While these landforms are continuously changing systems, the stability of deltas are important to coastal communities for many reasons, and their disappearance can have negative effects. They serve as a buffer for storm surges, protecting mainland areas. They serve as nurseries for a variety of marine organisms. They sustain and provide nourishment for biologically diverse ecosystems, and their soil serves as a filter that removes toxins from the water. Deltas are living laboratories where scientists can gather data to learn how to save these valuable ecosystems and the services they provide. The loss of a delta to sinking and sea level rise would result in numerous environmental, economic, and social impacts on coastal communities. NASA scientists are collecting data about this dynamic system to better understand the causes of this change to the Mississippi River Delta and what is at risk. The data will be collected into a model to forecast the recovery and vulnerability of the delta given the rising seas. Their framework for the model can be used for forecasting change in other delta systems around the world. Scientists use these data in their models to investigate questions like the following to better understand the Mississippi River Delta as a system and apply this knowledge to deltas around the world. How does water volume change over time as it flows through the delta? What role does vegetation play in stabilizing the delta? What are the inputs and outputs of sediment in the system? Which parts of the delta are changing, and what are the rates of change?
How do parts of the Earth system, such as ocean weather and mountains, interact with and influence climate change? This is a question of great interest to scientists. To address it, they measure precipitation in the forms of rain, ice particles, and snow that fall as ocean weather systems approach coastal mountains. They also study the short and long-term effects of this precipitation, as well as how local and regional levels are affected. Storm systems that occur in mid-latitudes, that is, between the tropics and the poles, are of particular interest to scientists as they examine how does precipitation in these systems behave? How does the precipitation that falls over the ocean differ from that falling over the coastline and coastal mountains, and why? And what is the role of clouds in the land's topography and the amount of precipitation that falls? Scientists use many methods for collecting data as they attempt to answer these and many other questions. Satellites in space can be used to monitor precipitation over vast areas, but may miss the variations over smaller regions. This is where the use of sensors on planes and in field locations allows scientists to take a closer look at what is actually happening on the ground and to help validate, or in simple terms, double-check what satellites are seeing from space. NASA's Olympic Mountain Experiment, or Olympex, was conducted to observe an area of temperate coastal rainforest called the Olympic Peninsula in Washington State. The experiment, which in reality was a set of experiments, collected data from ground sensors like rain gauges, snow cameras, weather radars, and balloon launch sites, and also used sensors on 3 different aircraft that flew through and over clouds in the region under different weather conditions.
Hi, everyone. I'm Michelle Thornton, reporting today from the beautiful city of Montreal, Canada, where I'm at the Ecological Society of America's annual conference. Here, I've been sharing information about NASA's Airborne program. Nearly every time we tune into news or social media, there's a story about how the northern latitudes are responding to a warming climate. This is especially true for the people in Alaska and Western Canada. We know that climate change in these regions is happening faster than anywhere else on Earth, causing widespread changes to habitats and to the plants and animals that live there. So how are these parts of the Earth system changing, and what does this change mean for those living in this region? NASA's Field Airborne campaign, called the Arctic Boreal Vulnerability Experiment, or ABOVE, monitors these phenomena and investigates the effects on ecology and people of the northern latitudes of Alaska and Western Canada. The ABOVE campaign seeks to understand how these ecosystems will change and how they may be able to stay the same as a result of climate change. ABOVE scientists use these data to answer the following questions. How is the Arctic sea ice melting? What factors control the rate of melting? What is the rate of warming of the ground that was once permanently frozen, often called permafrost? What factors control the thawing and decomposition of organic matter? How are lakes, rivers, and coastlines responding to climate change? And how are cycles of wildfires changing? What factors influence their frequency and severity? To help them better understand these questions, ABOVE campaign scientists use data collected from sensors flown on airplanes, coupled with field observations. Field crews collect very detailed information about vegetation, soils, permafrost, animals, and lakes and rivers, while data from airplane sensors observe larger areas than what is possible by a field crew on the ground. Combining field measurements with airborne data gives scientists a more complete understanding of this high latitude and fast-changing ecosystem. This is especially true when aircraft fly at the same time that field crews are collecting data.
How is fire related to air quality? This is a question that NASA scientists investigate using data collected by sensors flown in airplanes. The Fire Influence on Regional to Global Environments and Air Quality, or FIRE-XAQ campaign, studies the gases and particles released into the air from wildfires and agricultural fires from across the continental United States. These fires can have a big effect on air quality. In fact, the gases from wildfires, called emissions, can travel thousands of miles away and affect distant regions of the United States. This is where FIRE-XAQ campaign helps to provide important data that we need to better understand and forecast the effects of fires on neighboring and distant communities. FIRE-XAQ scientists use these data to investigate questions like the following. What chemicals are found in fire smoke? How do these chemicals affect the quality of the air that we breathe? How do emissions travel over space and time? And how do these FIRE-XAQ data compare to the same data collected by satellites?
You might have heard about the important role that microscopic plant-like organisms called phytoplankton play in the ocean food chain. But you might not know that phytoplankton populations change over the season. For example, in the North Atlantic Ocean, phytoplankton populations spike in the fall and winter, filling the water with high concentrations of chlorophyll, the pigment that gives plants their green color and enables photosynthesis. This abundance of phytoplankton is called a bloom, and blooms can be so large that you can see the population of teeny tiny organisms from space. During spring and summer, the phytoplankton populations decline and the chlorophyll in the water decreases. The cycle repeats again and again, season after season, year after year. Did you know that phytoplankton also affects the atmosphere? It's true. These tiny organisms might seem insignificant as they float from place to place in the ocean, but they play an important role as they interact with the atmosphere. For example, phytoplankton, just like trees on Earth, remove carbon dioxide from the air. Carbon dioxide is one of the most important gases associated with global climate change. So how does phytoplankton's seasonal cycle affect the atmosphere and other parts of the Earth system? This is a research topic that was addressed by NASA's North Atlantic Aerosol and Marine Ecosystem Study, or NAMES campaign. Scientists collected data about the ocean and atmosphere using NASA's C-130 aircraft along with the research vessel Atlantis to study these interactions. These airborne and shipborne observations were joined with additional information from floater sensors that drift around the ocean as they collect data. These multidimensional observations enable NASA scientists to answer questions like, do phytoplankton and sea spray affect the atmosphere? Is there a relationship between phytoplankton and the clouds above? Why do phytoplankton bloom in the early spring? How will this cycle change as the ocean warms due to climate change? And do grazing fish affect phytoplankton bloom?